I'd like to say hello to everyone joining us today, and also thank you for being here. I know for some of you it's good morning, and for others it's good afternoon. I think we're covering about 5 time zones here. I may be giving this presentation, but what I'm talking about today represents a body of work only made possible by the hard work and dedication of many other people. And I'm pleased to be joined by my fellow Simpson engineers today, Emery Montague, Frank Ding, Scott Fisher, and Gary Mochizuki, in giving this presentation. This whole project has been a bit of a journey, really, and it has roots in even older projects. To chronicle everything that we did to get here would take more time than we have, so I apologize in advance if I'm not able to properly credit everyone who has been involved. This presentation is mainly focused on the topic of increasing seismic capacity of cast-in-place anchorage using non-standard anchor reinforcing detailing. Also, I'd like to reiterate what Maria said. If we were all in the same room together, I would ask you to just interrupt me at any time and ask questions because it makes for a much better presentation. And while in the webinar format we can't exactly do that, you do have the ability to post questions in at any time. And as Maria said, we've got 3 different Q&A sessions throughout the presentation where we can address those. If it's relevant, be sure to include a reference to the slide number that your question is about. I think all but just a few slides have slide numbers at the bottoms of their slides. So let's get started. In trying to find a beginning for this whole project, it's kind of difficult. I chose 2008 mainly because this is when the topic of the effect of the new ways of calculating concrete anchorage breakout really started to begin to get noticed here on the West Coast. But it really goes back to the 2000 IBC. That was the first code to adopt the new CCD, or concrete capacity design method, for calculating the breakout of concrete anchors. And it wasn't until the 2007 California Building Code that adopted the 2006 IBC that we really started focusing at the anchorage provisions as they apply to seismic concerns here in California, at least. And one of the early concerns was the capacity of anchors in sill plates, just good old 2x4, 2x6 sill plates anchoring light frame structures. We went from having capacities of around 1,200 pounds per bolt down to something like 350 pounds per bolt. That turned a lot of heads, and a couple of folks started thinking about what we could do to see about rectifying that situation. And there's an engineer up here in Northern California, Andy Fennell, got a group of people together, put together a proposal to SEAONC, and was awarded a Special Projects Initiative to look at testing, both cyclic and static testing of sill bolts that are anchoring sill plates down to concrete at the edges of foundations. They approached Simpson, and we offered our people, our laboratories, and the materials to do this testing, and that ultimately resulted in changes to the code that took effect in the 2012 IBC to reinstate some of the previous capacities that we had been designing with for sill plate anchorage. Fast forward a little bit, and the focus started shifting to a type of construction that we've seen a lot in numerous areas of the country, and that is multifamily light frame structures over concrete podiums. And typically, these structures would make use of narrow shear panels that could develop pretty high overturning demands. Usually, the overturning resistance was provided by a series of continuous rods that would go from the anchorage in the concrete up through the structure, tied in at each floor level, along with shrinkage compensating devices, coupler nuts, etc. And when it came down to the podium level, if we take a look there, common detail was to embed the anchor inside the slab as opposed to running it all the way through the slab, because although you could get some more capacity, engineers had concerns over the aesthetics of that connection, over fire issues, over durability, and even just plain vandalism issues. So keeping the anchorage of the rods inside the concrete itself has been the desired approach. But when you do this, you're left with some pretty shallow embedments. On a 12-inch podium slab, you might get 9 inches of embedment. You're down around 7 inches of embedment when you're in 10-inch slabs. And coupled with the new CCD design methodology, this was really yielding some fairly low capacities. So as engineers started looking at typical demands, they came up with some baseline scenarios for 3-story or 4-story or 5-story structures